So this is part 5 of Advanced Engineering Mathematics Practice Final Exam. So picking up with 13, solve x prime equals 2, negative 1, 4, negative 3 times x with x of 0 equals column 1, 2 using matrix exponentials. Okay, so x prime equals this matrix 2, negative 1, 4, negative 3 for the rows respectively times x. We're going to let a equal 2, negative 1, 4, negative 3. So the eigenvalues here after performing the computation, lambda sub 1 equals 1 and lambda sub 2 equals negative 2. So the eigenvectors are v sub 1 equals this column 1, 1, and v sub 2 equals this column 1/4, 1. The matrix exponential is going to be e to the at. That's going to equal for this first row 4/3 e to the t minus 1/3 e to the negative 2t. Negative 1/3 e to the t plus 1/3 e to the negative 2t. Second row, it's going to be 4/3 e to the t minus 4/3 e to the negative 2t. Negative 1/3 e to the t plus 4/3 e to the negative 2t. And since x of 0 equals this column 1, 2, then x of t equals e to the negative, I'm sorry, not e to the negative, e to the at, x of 0. And so x of 1 of t equals 2/3 e to the t plus 1/3 e to the negative 2t. And x of 2 of t equals 2/3 e to the t plus 4/3 e to the negative 2t. So in the end here, we're going to wind up with x of t equals first row 2/3 e to the t plus 1/3 e to the negative 2t. Second row here, 2/3 e to the t plus 4/3 e to the negative 2t. All right. And now building on this, going to number 14, we want to solve x prime here, matrix here given as 1, 2, first row, 0, 1, second row, times x plus this column, e to the negative t, sine of t, using variation of parameters. So this is a non-homogeneous system. You get x prime of 1, 2, 0, 1, x plus this column e to the negative 2 sine t. So the system is x sub 1 prime equals x sub 1 plus 2x sub 2 plus e to the negative t, comma, x sub 2 prime equals x sub 2 plus sine t. So solving the second equation, x sub 2 prime equals x sub 2 plus sine t, x sub 2 prime minus x sub 2 equals sine t. So a particular solution will be x sub 2p equals negative 1/2 times quantity sine of t plus cosine of t. So x sub 2 equals c sub 2 e to the t minus 1/2 quantity sine t plus cosine t. Solving x sub 1 prime minus x sub 1, that equals 2x sub 2 plus e to the negative t. So substituting here in x sub 2, x sub 1 prime minus x sub 1 equals 2c sub 2 e to the t minus the quantity sine t plus cosine t plus e to the negative t. So using the integrating factor e to the negative t, e to the negative t x sub 1 prime, that's going to equal 2c2 minus 2c sub 2 minus e to the negative t sine t minus e to the negative t cosine t plus e to the negative 2t. Integrating, then e to the negative t x sub 1, that's going to come out to c sub 1 plus 2c sub 2t plus e to the negative t cosine t minus 1/2 e to the negative 2t. So x sub 1 equals c sub 1 e to the t plus 2c sub 2t e to the t plus cosine t minus 1/2 e to the negative t. So we wind up with this general solution here. For x sub 1 of t, that equals c sub 1 e to the t plus 2c sub 2 t e to the t plus cosine t minus 1/2 e to the negative t. And then for x sub 2 of t, that equals c sub 2 e to the t minus 1/2 times the quantity sine t plus cosine t. So now moving along to number 15, if we consider the nonlinear system here, x prime equals y minus x cubed, y prime equals negative 2x minus y, Part A, determine the equilibrium points. Part B, determine the Jacobian matrix. And Part C, determine the linearized stability. So stability analysis problem. So x prime equals y minus x cubed. Y prime equals negative 2x minus y. So forming the algebra here, the equilibrium points are going to satisfy the following. Y minus x cubed equals 0. So y is going to equal x cubed. Negative 2x minus y equals 0. So y equals negative 2x. X cubed set equal to negative 2x. X cubed plus 2x equals 0. X times the quantity, x squared plus 2 equals 0. So the only real equilibrium after we're solving here for x, that's going to come out to x equals 0, and then y equals 0. So the Jacobian is jxy equals this matrix, negative 3x squared 1 first row, negative 2, negative 1 second row, and at 0, 0. So j of 0, 0 equals first row 0, 1, second row negative 2, negative 1. So the characteristic equation is lambda squared plus lambda plus 2 equals 0. So lambda equals negative 1 plus or minus the square root of 1 minus 8 over 2. That becomes negative 1 plus or minus I square root of 7 over 2. So the real part is negative. So the equilibrium is a stable spiral, and the nonlinear system has a locally asymptotically stable spiral at the origin. Okay, so that's part 5. Thank you very much and have a great day.